Let's not forget that. And glad I haven't really gotten into anything important. If you're just now tuning in to the recording, you missed my gripping and entertaining small talk. So now I just want to let you all know what we're up to for this week. So this week we're going to be getting into, as I said, the kind of practice end of what we're doing in this class. So today I'm going to tell you some conceptual stuff just about images in general and how they work digitally. So we're going to talk about some kind of big picture things that apply to just digital images in general. And I'm going to show you a few things that you can do in Google search that will probably be helpful to the first assignment. And basically for the first assignment, we are doing something different. So if you have any questions or it's not adequately explained in the brief, please just send us an email. We're happy to answer your questions. Like I said, I got a really good question from someone who may or may not be here today. But I'll try to just address any of those things. But basically what we're doing is we're making the first assignment into a search assignment where we're sort of just giving you all an opportunity to somewhat aimlessly grab images and just kind of explore what's out there in preparation for potentially using those images in a future assignment. So it's sort of a double bonus, hopefully. So I'm going to spend some time doing that today, and then on Thursday we're going to get started with our sort of official very first day in Photoshop, and we're going to spend the entire class period on Tuesday doing stuff in Photoshop. We might spend like 5 minutes today doing stuff in Photoshop. But yeah, basically we'll just sort of jump in and we'll jump in with both feet. In other words, we will be doing it a lot. So let me go ahead and get rid of my notably not lo-fi background music today. And I do want to talk to you about digital images in general, and so we'll kind of work outward from this. We have sort of this question, what is a digital image? And I mean, obviously, we can answer that in a very sort of common sense way, like, that? Thanks, Meg. Got that. We know that. So I think what we're going to be doing is maybe answering it in a much more thorough way and in a more accurate way. Put simply, and again, I'm sure you can find some exceptions. There are all kinds of bizarre little file formats out there. But in general, there are two types of digital images. There are raster-based images, and there are vector-based images. And vector-based images, I would also lump into that anything that's 3D. And the basic difference between those two types of images, or two types of files even, are, because an image is just fundamentally a file, right? It's a digital file, is that vector-based images, and this, again, can be extended to 3D images, are really mathematical abstractions that are displayed in a certain way. We've all been there. Displayed in a certain way so that they appear to be the thing you're seeing. So basically, you might see an image that this is probably a typical vector-based image, is usually used for like logos or illustrations, anything that has kind of flat shapes. The image may look like a cat sort of possibly questioning its decisions about its grooming habits, but oh no. In fact, what's behind this image is something that looks probably more like this, where it has a specific set of points and a specific set of lines with a specific set of instructions that are really just coded into the computer that may say even things like circle 30 pixels, right? Or something like line starts here, ends here, has a hump in the middle. So that sort of like level of markup or description. Whereas on the other end of the image spectrum, we have raster images. And those are also called bitmaps. They're also called pixel-based images. Sometimes people just refer to them straight up as their file name. So a lot of people refer to images as JPEGs these days, which is a very specific format of image. But, you know, it's sort of OK with that, I guess. But it's important to realize that raster images, and we're going to look at some in Photoshop of both of these types. It's important to realize that raster images are made up entirely of and only of pixels. That's all they contain, and that's all that they ever will contain. Now, just to confuse you, and this isn't going to be on the exam, there are, in the last maybe decade, there are now some combination types of images. So out in the wild, you may very well see a PDF, for example, that has both this and pictures and maybe even video embedded in it. That's kind of a special purpose type of thing, right? Used for large documents or things like that. That's not the type of document that we're going to see a lot in this class. And in any case, if there is a combination file, it still contains one of these and one of these. So it's sort of maybe not even that relevant to talk about that stuff. But just want you to be kind of aware that they exist. So as I said, over here in the vector section, or in the sort of vector file, I had described some ways of maybe coding this image out, and we'll look at this in more detail later in the semester. But yeah, you might see something like circle, 40 pixels with a set of coordinates. And that's considered human readable. It might not be readable by all humans, but if maybe you don't like numbers. But technically, yeah, it is human readable, right? Like we can read numbers, we can read words. What you get when you get a pixel image is something that is not even remotely humanly readable. Pixel-based images usually come what's called encoded. So you'll see basically just like a gobbledygook of alphanumeric characters if you look at the code of a pixel-based image. So getting back to the vector versus raster, there's a huge amount of difference in vector and raster files. There's also areas in which they kind of can coalesce or overlap. So any vector image can be made into a raster image. In other words, you can take a capture of it, which is what's happening here. In order for this, which used to be a vector image, to even display on my screen, it's being displayed in pixels, right? Because the pixel is the foundational unit of all digital display devices. So what you get with vector images is you usually get a sort of snapshot of one, or you see vector images that are actually converted into pixels. And when they're converted into pixels, you can start to see what is one of the major drawbacks to pixel-based art. And that is, in this case, you can see that the pixel-based art is not scalable. And before you think about arguing with me on that one, it's true, there are some amazing things that algorithms can do now to scale images. That's been kind of a problem in computer graphics for a good many years. And you can do some amazing things with scaling small images now. Just because you can doesn't mean you should. And in general, I would still stand by this sort of assessment that it's always better to not scale pixel images. Because what happens is, and you can see this super clearly in this example, the data literally just falls apart. There's not enough data for us to even know maybe what this word means, right? Where if we can sort of see it in the vector preview, we can see really clearly that it says ice. So we'll look at some of the kind of finer points of scaling images actually later today. But I wanted to kind of just let you know. So if we think sort of globally about the pros and cons of just vector images, and by the way, vector images are the type of images that we will be using the least in this class. I just feel like it's really important for everyone to walk away from this class, at least knowing that such a thing exists. Because if you take any courses in graphic design or certainly any courses in like industrial design, you would be probably relying on vector-based images. So vector-based images are awesome. You would probably create them in an app such as Adobe Illustrator, or you could also use an open source app called Inkscape. They're super precise. You can take a design from a vector-based image and put it to the 10,000th of an inch, which is, or probably even smaller if you massage the units. So for doing stuff like technical drawing or anything where you have to actually know what size something is, it's a good format to work in. It works well for illustrations and graphic design. So as in both of our examples, anything with kind of solid tones and not this sort of continuous tone that you would see in a photograph. Those are great things about vectors. Another thing about vector work that's really awesome is that even if you have a very complex vector file, it probably doesn't take more than 10 megabytes of file space, and that's for a ridiculously complex vector file. And with pixels, pixels and video for that matter, which is pixels in time, pixels take up a ton of hard drive space. So if you're working a lot with Photoshop and working a lot with video, you will find that you potentially need to purchase that, storage account from Google Drive or buy yourself that extra hard drive. Not probably with the amount we'll be doing it in this class. So the drawbacks to vector-based file formats is that they're a little bit more specialized. So as I pointed out before, they're used mostly for illustration and design. So they're used mostly by professionals. There's not a lot of operating system level software that deals well with vector stuff. So what do I mean? Like if you have a Windows machine and maybe you're trying to use something like Image Viewer or Microsoft Paint, like don't even bother, it doesn't work. So you might have to actually have special software, in other words, to view and edit them. So blending doesn't really happen. You can see over here in our image, there really is no blend. There's 3 shapes that are stacked on top of each other, and it looks like a blend. That's because doing what are called fountain fills or sort of, areas where you can really get a clearly modeled sense of shadow and light, well, you should use pixels for that. That's what you use pixels for. And yeah, then lastly, as I said, continuous tone doesn't really exist. So you always have to sort of like commit yourself to using solid shapes, lines, colors, which works great for design and technical drawing. So over in the raster image section, I would say probably like 98% of images that you encounter on your various devices are probably going to be in this category of raster images. There's one really notable exception for vector images that I might mention. But most of the images that you will use in this class and most of the images that you'll come in contact with are indeed raster images of some form or another. So they're really great for photos, anything that needs continuous tone or this sort of gentle transition from one color or shade to another that you would see in a photograph. I guess one of the good things, I'll put this under good things, but it can be a bad thing, is that you can you have the option of compressing raster-based or pixel-based images. And so that's something that you all are probably seeing a lot in your own life and might not even realize it because you're just not saving it out of Photoshop. But most of the images that we encounter out on the internet or on social media have been compressed in some way. And that's because, obviously, if you compress it more, it's faster to download and makes people less frustrated. So back when I used to be a full-time internet designer, one of the biggest things that we would try to work on with sites was the speed at which they would load. Because they've done studies that people basically have the attention span of gnats, and that if it takes more than a half a second for a page to unload, or for a page to load, that people are just gone. And you just lost your customer. So, so getting something in front of their face really quickly is a huge priority in that field. Bad things about pixel images is that they're not very scalable, which we'll talk about that today. When I say they're not very scalable, I think art in general, especially visual art, I think it might be Picasso or maybe Andy Warhol, some super famous artist made this super famous quote about how art was what you can get away with. And I think that that's actually kind of cheesy, but kind of like totally true. Because basically, if people see it, it's a problem, right? If people can see it and say, why did you mess that up that way? Then yeah, why did you do that? Everybody noticed, like that's not a bad thing. But if nobody notices and nobody says anything, it kind of doesn't really matter what goes on behind the scenes if they're presented with something that looks convincing. And so images, and especially image compression, it sort of falls into that category, right? It's like, well, how terrible do you want your image to look? Or how terrible do you feel comfortable with your image looking? Sometimes a tiny bit of terrible is okay, because nobody will notice it, right? And then other times, it's really critical, and maybe you don't have any sort of wiggle room. So we'll sort of think about that a little bit when we talk about scaling images. So there's a couple of contexts in which you see raster images. And probably, I'm guessing that like 98, 99% of the context that you all and me would see raster-based images are going to be in this kind of low internet/screen space. In other words, we're witnessing them on the screens of our devices. We're probably seeing them delivered through some kind of a web page or web, I guess maybe if you're feeling really diligent, you would actually go to the UW-Madison Library's website, instead of using Google. But yeah, wherever you're finding it, it's basically doesn't change the resolution much. And so inherently, what we're seeing on our screen and what we're seeing on the internet is going to be low quality or low to medium quality. If we do see a higher resolution image, which certainly there are many out there on the internet, we're probably specifically looking for a higher resolution image. And why would we want a higher resolution image? I can think of a couple reasons. So one answer to that question would be, I want to make this giant poster and I want to hang it in my dorm room. I want to make a big print, basically. What's the other? Any other? Yeah. Sure, I have a really big screen and I want to use it as a computer screen background. That actually does need quite a few pixels usually for a contemporary, screen. I would say the other reason that you would potentially want a high-resolution image of something, and this is something I do a lot when I use my fancy camera, I have the ability to take a picture of a room like this and then make it a picture of that person. Because I have that many extra pixels, I can throw that many extra pixels away. And it gives me a sort of, still a pretty decently high-resolution picture that I can crop into. So in general, like, in my sort of image acquisition world, it's always better to have more pixels. Because you can throw away pixels and there's no penalty, right? And also, there's really no penalty for hard drive storage. On the level of a photo collection, shouldn't be any problem. Until you get into kind of like the post higher than a terabyte range, then you have to start thinking about actually paying for storage. In which case, there are lots of services that you can avail yourself of. I currently do Google Drive, but I've used lots of others, and they're all fine. So yeah, in general, having a sort of library of high-resolution images it can be a little bit burdensome if you have many gigs of data and you have to move it around different places. But as an artist and as somebody who works with images, having a lot of high-resolution image data is like having, I don't know, like a lot of ice cream before a party. It's just a ton of stuff that I can do stuff with. So I think of it as a net positive. The other reason I'm going to probably say that in general it's always better to shoot or scan or however you're getting your images, basically to just always opt for more pixels and more resolution. The other reason that it's good to do that is that it just gives you the option later on where, especially if you're traveling, you can't always go back to that place and take that picture again, right? You want to get it right the first time. Excuse me. So yeah, I would say always, if you're working with pixels, go high. We're going to see in a few minutes that you can't really invent pixel data. In other words, if you have a really tiny pixel-based image, you're going to wind up with a really tiny pixel-based image. So if you have a larger image, you can always make it smaller, but you can't make a small image larger successfully, always. So basically with pixels, and we'll talk about this when we get into Photoshop, with pixel size, the only thing that really matters is pixel size. You'll see some slightly antiquated ways that Adobe deals with image size, and it's really still kind of coming from that background of being, well, basically making the assumption that you're making a print. And so if you're working for screens, which probably most of us are, all you have to really be concerned about if you're only going to display it on a screen is the pixel size. So if you're making a poster or you're making an 8x10 photo to frame and give to somebody, then certainly you would have to think about the dimensions relative to the resolution. But for a screen-based kind of context, which I'm pretty sure most of us are in, pixel size is really the kind of important thing. So pixel size is also a little bit simpler to think about in your brain. So I always got a little bit confused with width, height versus resolution. So with pixel size, it's super simple. It's width and height in pixels. That's it. So this little kitty image down here is 128 by 128. It's this big. This image over here is twice as big, literally twice as big, width and height, right? And it's 256 by 256 pixels. So we'll look at some other examples of images and sizes in Photoshop, but this is just kind of basically where we're headed with this. So thinking about this idea of looking under the hood of the image, I did want to show you at least once what a JPEG looks like. And this is basically what you get. And I think we can all agree that this is no language that it's like, it could possibly be like the black speech of Mordor, but I'm not 100% sure. It's no language that we have the ability to decipher. So we're just not even going to worry about it. There are ways that you can write JPEGs that are not encoded. And potentially that would be an interesting advanced topic of study for the code section of the class. But for now, we're just going to kind of put this away and pretend it doesn't exist. And I have a few examples that I wanted to show you all. So I have these two examples of a vector file. And so this was actually a vector file that I made a series of prints based on these vectors. And you can see how there's a lot going on in this artwork. So these are actually individual little leaf designs that I traced off of photographs, and then I put them into a code engine and kind of replicated them in a pictorial space. But this is the sort of vector image. And I would say, like, in general, this is like the vector image in all its glory with its, like, you know, infinite zoom. It's very satisfying. And I mean, there are definitely reasons why you would want to use a vector format here. Now, where did I kind of go with this? Well, certainly at some point, I think I took this print and I actually sent it out to have a printing plate made. And in order to do that, I had to rasterize it, which that's the sort of fancy word for when you take a vector file and you basically bake it into an image. And you can see here is the rasterized version. And now you can see, okay, it definitely, like, really clearly breaks down, right, into its constituent pixels. So the reason I made a copy as a raster image was because at the scale that I was having my printing plate made, which was probably about like this, you can see it's perfectly clear, right? And that's adequate resolution for that particular process. So this is just to sort of illustrate like how you can go back and forth to a certain extent. And you know, there are certain reasons why you would potentially want to use these types of images. So if I go into Photoshop, I want to also show you what I was talking about with regard to scaling images. So I have a couple of really low quality images here, and to be honest, it's kind of funny. I actually have a hard time finding images that are low quality enough to illustrate this example. And then Photoshop over the years has actually gotten better and better at scaling images, so it's actually getting harder for me to show you this terrible thing. But you know, it's fine. It just means the tool is getting a little bit smarter than us. So basically this image, it's, you know, like very basic, nothing special. It's a vulture. It's about 200 by 200 pixels. So if I wanted to verify that and I were in Photoshop, I would just come in here to image size. And then you can see if this unit is in pixels, you can just see it's straight 200 pixels by 200 pixels. Now, you may also notice that if you're looking at your images in pixel size, you will notice that there's an automatically assigned resolution. It's 72. 72 is kind of like the magic number for screen resolution. So that's the actual resolution of this thing. And that's why internet images have sort of adopted that as a kind of so-called universal resolution. Now, are there exceptions to that number? Yes. Especially like if you have a retina screen, then technically your resolution is probably closer to 144. But it's, in general, when you're designing stuff for the internet, it's a good idea to design things for internet consumption at a somewhat lower quality than you would normally do, because the idea is that you want your work to be readable and accessible by people that may have computers that are lesser equipped than your own, right? So in general, I think sticking with a resolution of 72, because that's kind of the base standard in the world, is a good idea, even if you yourself might have like a nicer computer. Just because, you know, it's kind of frustrating to produce really nice stuff that nobody can really see. Or appreciate. So this image right now is 200 by 200 pixels. And as you can see, I can come in here and I'm just going to type something kind of outrageous. So I'll type like 2,000, which would be increasing it by a factor of 10. And you can see here in the preview window, I think I can actually make it a little bit bigger, what happens. So it goes from being this kind of like ooky set of really obvious looking pixels to this artificially smoothed, kind of algorithmically smoothed result. It's a little painful to look at. It's not necessarily, I mean, it doesn't look like a really high resolution image, right? You might, I mean, we could push it even further and push it to like 4,000 pixels. And now, this is basically what false advertising is made of. So a lot of times if you're shopping for like bargain cameras or they'll say, wow, this camera operates at 8K resolution. And then you get the image and it's like this. And it's basically because they've taken a tiny image and they've upsampled it. So this is called upsampling. And if we look back at the image adjustment thing here, you can see it says resample is checked. If we check off resample, it won't let us make the image any larger or smaller because we basically just turned off that option. So under resample, I'm going to actually go back one step to before when it was little, and I'll show you some other methods of resampling. When we took it to 4,000 pixels before, I'll just do that again. This image right now is on the automatic resampling selection. So some of them do better than others. You may notice that the nearest neighbor is probably going to look the worst. The nearest neighbor is actually the most accurate if you're actually concerned with accuracy and the accuracy of the color of certain pixels. It doesn't look good, but it is actually doing exactly what it says, which is basically finding the next pixel over and doubling it or replicating it. There are other scenarios, other resampling scenarios that are based on finding smooth gradients, reduction and enlargement. Definitely choosing one of the enlargement ones does give you a better result if you're actually enlarging the image. But again, it's like, I don't know, is this better? It's really, it's kind of hard to tell. So here's my recommendation in general for scaling up images in Photoshop. I've tried to stick to something called the 20% rule, which is basically, and it's not a real thing, don't look it up, it's just my personal thing. Some people actually say the 10% rule, which I don't, it doesn't really matter that much. But the basic gist of it is if you start with a 200 pixel image, so starting with a 200 pixel image, don't add maybe more than like a fifth of the image's pixels back in. In other words, don't scale it by more than 20%. So here, if we scale it by 20%, what's going to happen? Maybe we would have 240, I think. I'm not very good at actual math. I'll put it on auto. And now you can see it's not really that much bigger, but we don't have any ooky algorithm ska all over it. So that can be kind of helpful. It's also kind of disappointing if you have a little image and you need to make it bigger. You're not going to like what I have to say, so this is your downer for the day. This is my advice. If you have a little image and you need to make it bigger, go get a camera. Basically. I'm sort of joking, but kind of not really. I mean, there's only so much you can do, I guess is what I'm saying, and it's just one of the limitations of pixels. And I also think a lot of it depends on context. So like this image that maybe has like slightly pixelated edges, if I wanted to display it at this scale in an art piece, could I do that? I don't know. Some ways that I could maybe see you doing it, if you had it in there and it was maybe covered with some leaves and there was stuff in front of it and there was stuff behind it, then the viewer's eye is going to be so distracted they're not looking at the boundary of these feathers. So some of that is just stuff that you have to kind of like, ask me, ask your TA, and get some other people's opinions on whether they think it's kind of ooky or not. Sometimes that stuff is a little surprising. I tend to be, for my own work, I tend to be a little more critical than other people are. And then I show people stuff and they're like, oh, that's totally fine. And I'm always like, really? So for that reason, it's good for me to get input from other people because it's usually pretty good. other things that we can kind of think about with regards to pixels, and I guess this is probably maybe just a continuation of like what not to do. I'm going to show you now how not to save it. So probably a decent way to save this image would be to save it as a PNG or a TIFF. You may notice that it's a JPEG right now, and that kind of has some baggage that goes along with it. So that JPEG is compressed. And so if we're saving this for our own purposes, we probably want to save it as a PNG because it won't get kind of over-compressed. Well, what do I mean by over-compressed? I will tell you in a very short time. So I'm going to take this now and save it as a JPEG. And again, JPEGs are a really popular file format. So if you're finding images on the internet, they're probably going to be JPEGs. Doing that thing that I just did, where you save it as a PDF or as a PNG rather, can actually kind of basically short circuit the automaticness of the compression. So if I were to just have opened up that image in Photoshop and then hit save, it would compress it a second time, which is bad, right? So if I save it now as a JPEG, and I use the Save As dialog box, which is different than just saving it, now I have the option to basically tell it how much quality to give it in the compression. And so you can see directly, hopefully, on the screen. Let me make it really bad. And actually, let me just zoom in on this section a little bit so you can really see it. Yeah, you should be able to see it now. So save as a copy. I'm going to save it as a JPEG. Now, there is nothing wrong with the JPEG file format. What you want to avoid, doing it in this sort of large file zone is almost always going to give you a very minimal level of compression. So it means that the file size of your file will be slightly larger. I think that's fine because most of us have decent bandwidth. You know, we all have some kind of devices to have storage. So saving it, I would say anywhere above 10 is probably what I would consider the safe zone. Saving it with a compression level of 0, well, you can see what it kind of does to the image. I guess ooky is like my word of the day. It makes it all ooky and stuff. It basically just kind of rains these cube-looking compression algorithms all over your image. And I'm sure that you've seen probably plenty of images on social media, TikTok, whatever, that are actually sort of done like this on purpose as kind of an effect. But mostly it's considered like a deleterious effect, and it's considered something that's, you know, really like, oh, you poor thing, how could that have happened to you? And that image. So sad. So generally we want to kind of avoid that kind of over-compressed look, unless you're doing it on purpose. So yeah, so those are two things about some digital images.